Hey everybody, this is Garrett with Earth and Time, a channel where we explore Earth as well as human history, and specifically where the two intersect. Today we're actually going to check out a new museum for me. We're actually at the Boston Museum of Science, and as you can see by this 1960s replica of what they used to think a T-Rex looked like behind me, we're going to see some dinosaurs, one of my favorite creatures or types of creatures to explore with you all. So I've never been to this museum. I'm going to learn right along with you. Let's get to it. But before I go in, I do need to show this T-Rex. So this was a model made in the 1960s, and at the time, there were only about 5 T-Rexes or portions of T-Rexes known, and this is what they thought the T-Rex would look like. Now we know they probably didn't stand so upright, and there have been, a couple dozen T-Rex skeletons discovered, and we know a lot more about them. But in the 1960s, this is what they thought they looked like, and I wanted to share that with you all. And one last comment with my friend Theodore the T-Rex behind me. I feel like I'm watching one of these old movies, or like that could have been a prop in one of these old movies like BC or Caveman or something like that. That's what this replica reminds me of. All right, so made it into the museum. It's $33 if you're not a member. They happen to have today, because I'm a member of the Houston Zoo, of all things, it was actually free for me to come in here and come visit the museum. This is pretty amazing already. I'm really impressed. All right, let's go find the dinosaurs, and I heard they have an earth science section as well. Let's go check those out. So I think I already found somewhere I'm really interested in. Natural mysteries, find connections by classifying. It looks like they have a whole bunch of rock samples, including, look at this piece of malachite that they polished. The size of that thing is gigantic. Here's my hand on it for scale. There's an amethyst geode tube that's, it's about 3 feet long. And a whole bunch of really cool mineral displays, including some opal from Nevada, from Humboldt, Nevada, area I know pretty well. And here's some tourmaline. Here's some black tourmaline. Actually met one of the tour guides of the Freedom Trail, just happened to be talking to him, Captain Pickles, shout out to you. And he was asking me about black tourmaline. Whoa, and check out this crinoid fossil. So crinoids were ancient sea creatures that were attached to the bottom, and the top tendrils would catch things like plankton and maybe small creatures and eat them, but they were what were known as sea lilies. Here's an ancient horse, and as many of you have been watching my channel for a long time know that horses and camels both evolved here and started here in North America and eventually went extinct, and then of course were brought back over. And there's a saber-toothed cat and a graulator track, and we saw some really cool graulator tracks when we went and visited the dinosaur site in St. George, Utah, so you can check out that video of mine as well. This is a really cool interactive area for kids. They have a little school here to learn about nature. You'll see they have animals like polar bears behind me. They also have some ancient tree stumps back here from 300 million years ago called sigillaria. And these are ancient trees. And here they're speaking my language from the museum's geology collection. Look at that. They have some, looks like pyrite and marcasite, some really nice mica in here, some gorgeous crystals, and I'm not sure what everything else is. They have some beautiful gems, some malachites in here, looks like some chrysocolla, some magnetite. We'll have to go walk through some more of the sections, see what other kinds of rocks we can see. And they also have a section with fish and different types of animals. They have a little shark up there. They have a bunch of seashells. Study of seashells is malacology. And they have some really interesting, amazing examples of seashells with spectacular designs here. So I have a giant clam here. That's one big bowl of clam chowder right there. Of course, because I'm in the Northeast, the American lobster, and look at the size of that dude. They have displays on jellyfish, love jellyfish, some other types of coral builders, sea anemones, cephalopods, and more cephalopods. I haven't found the dinosaurs yet, but I did find a little river system here talking about different fish, including one called a pumpkin seed sunfish. That's interesting. Never heard of that kind of fish before, but here you go, a pumpkin seed sunfish. There it is. There's a sign I've been looking for. Let's go check out the dinosaurs. But first, muskrat. All right, check this out. They have a lot of different samples here, including, check out this petrified slice of a redwood tree. So this will have been cutting down the trunk as opposed to across of it where you can see the rings. But absolutely a gigantic piece, must be over 10, 12 feet tall. A beautiful meteorite. And it says it landed here about 4,500 years ago. And lots of malachite and azurite, which are spectacular and are actually copper ore, so they're a copper-based mineral. So it gives them those beautiful colors. And look at the size of this piece of petrified wood. Wow. I'm guessing this must have come from Arizona, from the Chinle Formation, which is the same formation that makes up the Petrified Forest National Monument there in northern Arizona. But check out this log. So it looks like you can still see the bark, but this is all rock, and this was all rock that was petrified through a process called permineralization, where minerals actually replace the carbon inside of it. And that is often the mineral that replaces it is silica, really red, which means the silica bonded with or had iron within its structure, which gives it that red color. Here's a piece of quartzite and schist. So this is a metamorphic rock, one of the three types of rocks in the family. Remember, it's metamorphic, which are rocks that have been changed by pressure and temperature. There's igneous, which are volcanic rocks in origin. And then there's sedimentary, which are deposited by things like wind and streams and ocean processes. So gravity and water and wind. And here's a nice piece of granodiorite. So this would be in the igneous family. Kinds of fossils they have here. They actually have some fossils from the Permian. So that the Eops here, which was an amphibian that lived during the Permian, so the time before the dinosaurs. They also have some ammonites in here, which are cephalopods, and those are just their shells that are preserved. And they have a little reptile called a Kikasaurus. So it's a reptile I'm not familiar with, but it's a swimming reptile. So from the time of the dinosaur, early time of the dinosaur, the Triassic. Here you get an idea about the timeline. So going from Paleozoic, so time before, if you will, the dinosaurs, will use that because most people are familiar with dinosaurs. So there were no dinosaurs or mammals before this time. Amphibians, trees start coming around, early versions of reptiles, and then by the Mesozoic, now we have the time of the dinosaurs. And eventually dinosaurs go extinct and we have the time of the mammals, all the way to what's known as the Cenozoic. It's a Eurypterid. These are sea scorpions, one of my favorites from before the time of the dinosaurs. Asking about crinoids. So here you go. Here's a picture of a crinoid from the Devonian. So they are much older than the time of the dinosaurs. I was asked that question earlier. It actually says here that there are still crinoids around, and they're closely related to starfish and sand dollars. Cool. Here's a full-size model of what they think a T-Rex looks like today. If you remember the T-Rex we saw on the outside of the museum standing up, very 1960s, 70s movie, BC, old school dinosaur movie, but this is actually what they think the dinosaur, the T-Rex, actually looked like in its shape. And it is massive. I barely come up to its knee. Really, really cool to see this replica of the T-Rex. Here is a Triceratops. So Triceratops lived at the end of the time of the dinosaurs and would have seen the meteor impact and gone extinct as a result of that. And they would have lived at the same time as the Tyrannosaurus Rex. This is Cliff the Triceratops that we were just looking at from the Hell Creek Formation, North Dakota, from 65.6 million years ago. So that's when the meteorite impact hit. The Hells Creek Formation, which is known as the Badlands of North Dakota, South Dakota, Montana, and we can see that here on the map. So it came from this kind of general region. There's a lot of late Cretaceous, really close to the time of the extinction event, dinosaurs that are found in this area, including T-Rex as well. Here is a replica or a model of a Triceratops. So the one we were looking at, Cliff, is actually a real Triceratops, mostly intact, which is pretty impressive, but this is a model of a Triceratops. Here's a T-Rex track, and they said we can put our foot in there. Oh, so it gives you an idea of my foot. I'm a size 11 shoe compared to a T-Rex track. Eubrontes tracks. So Eubrontes tracks and Graulator tracks. We can see both those also in the western United States. And if you can't see the tracks, you can see the right toe, the middle toe, and the left toe coming around. I'll pull my hand out of there for focus so you can see where the dinosaur stepped right there. Brontes would have been something like a Dilophosaurus. It could have been a Dilophosaurus because we don't have a body fossil to go with the trackway. We're not positive what created it, but it would be a creature something like this. And you can see that where the trackways, where they found them at, are here in green. Well, this is cool and something I haven't seen before. It says budding heads, Gigantosaurus versus T-Rex. So on the left-hand side here is a T-Rex skull, and I'm assuming a full-grown adult T-Rex skull. And on the right-hand side here's a Gigantosaurus skull, and quite different looking. And you can tell and imagine as a paleontologist, if you found one skull and found the other, you'd realize you had a different species. One is from South America, that's the Gigantosaurus, and it lived about 115 to 90 million years ago. And then the other one is the T-Rex, which lived in about 75 to 65 million years ago or so. Very, very different morphologies in the skulls, but both meat eaters and both dinosaurs. Talking about dinosaurs, you can see the dinosaur family tree, and it's really broken into two sections, what they call ornithischians, which are the bird-hipped, and saurischian, the lizard-hipped families, and you'll see how they can branch out and look a little bit different. So things like the T-Rex are in the saurischian family, and Coelophysis, Dilophosaurus, Allosaurus, my favorite dinosaur. And then you have the ornithischian, or what they call the bird-hipped, the Stegosaurus, the Ankylosaurus, the Triceratops, which were a different family of dinosaur. So how do we know about dinosaurs? Well, you have a few different things. Of course, you have the body fossils. Everybody's familiar with those. You also have trackways that actually recorded their movement. Here you can see a trackway right here. There's a trackway up here, and you can see where a dinosaur, probably Eubrontes, a Dilophosaurus-like dinosaur, was walking through a muddy substrate, and then their molds got preserved because they were quickly washed over by some kind of storm event or some kind of event that preserved the footprints. But we can also look at fossilized, what we call coprolites, or fossilized dinosaur poop, and get an idea about what kind of material was inside of the coprolite. So they can see, in this case, there's some plant material in here. So this must have come from a plant-eating dinosaur from the Jurassic. I have a little model of a Stegosaurus in here. Look at that fossilized frog. And a fossilized dragonfly. Well, that was a pretty cool exhibit. A giant femur over my shoulder here. That's a pretty cool exhibit, learning a little bit more about dinosaurs. And one of the things I learned is I really need to get to check out these Eubrontes tracks next time I'm in the Northeast, so I can go check out that trackway. I have a real love of dinosaur trackways. All right, let's see what else we can explore in this museum now that we've seen the dinosaurs and the rocks. As I'm walking out, I found a couple more fossils. There's a crab, and there's a creature called orodont that lived here in North America. It actually went extinct. They don't exist anymore, but it's a kind of mammal that's, if you took like a cat and a deer and maybe a pig and had a love child, it would look like something like an orodont. Look them up, they're pretty interesting. And here's an old turtle shell. And they have some dinosaur eggs. It doesn't say when they're from or where, or what type of dinosaurs, and they have a dinosaur bone. A fossilized pine cone, and there that's been cut in half. That's really cool. And some more crinoids. And a beautiful piece of petrified wood here, where you can actually still see the tree rings. Oh, and check these out. These are cephalopods, so these are squids that lived in hard shells, basically. And here's one called bentonites. There's a big one right there. That's quite large. That's a good 1.5 feet, 18 to 24 inches. And they have some trilobites in here. I like trilobites. They're like little pill bugs. They actually can roll up, and I actually covered those in some of my shorts if you look. I have some examples of those in some of my other videos. And a dinosaur looks like it's another prop from a movie. Okay, I've got to check out, what is this Arctic adventure? All right, they have little holes in the ice. And I guess we're learning about studying animals in the Arctic. Little ice climber up there. Gotta say, it has a very relaxing vibe. The music's relaxing. Being out here in general is relaxing. Kind of cool. You can come in here and they talk about how they're using drones for studying ice sheets and glaciers. There goes a narwhal, a pod of narwhals. Here showing how they're taking measurements and even ice cores. So coring is really important to understanding the story of a glacier, and even for environmental studies and weather studies. This is cool. This is showing all the ice cores, and it's talking about how they can measure the amount of CO2 in these ice cores, which is one of the reasons we know there's more CO2 in the atmosphere today than there were thousands of years ago. Well, that was cool and super unique. I've never seen an exhibit quite like that. But it's neat how they're tying how they do science in glaciers, which actually is really is a subset of geology in a lot of ways, with understanding climate and understanding the history of the Earth. Really cool. All right, I decided to go check out the other wing here. So moving away from the dinosaurs, I'm not sure what's in this. I'm what's now known as the green wing. I started in the brown wing, and it looks like they have stuff on animals here, New England habitats. We're talking about the various types of animals you can find here, from black bears to an eastern cougar. The beavers, size of that beaver, so that's the size of a beaver compared to a person 1,000,000 years ago. There were giant beavers running around here. That's crazy. And a creature I have yet to see in the wild. I've seen most of these creatures, even a cougar in the wild, or a mountain lion, but I've never seen a moose. Definitely on my list of creatures I would love to see someday in the wild, but from far away. All right, well, I did find another fossil. This is an ichthyosaur, and interesting enough, the ichthyosaur is a state fossil in Nevada, and they're actually a swimming reptile, more akin to a dolphin, if you will, because they had to breathe air, than to kind of the dinosaurs we think of. In fact, it's not a dinosaur, it's a swimming reptile. So that's the ichthyosaur. All right, here's an interesting one, In Search of Earth's Secrets. Let's see what that's about. Sounds like something a geologist would like. I was talking about things from geography to geology to paleontology. That's pretty neat. Earth is 70% ocean, 30% land. A little bit about the meteor impact that led to the extinction of the dinosaurs. A little bit more about that and how they actually found layers of what's known as iridium, which is a type of material that's deposited during meteorite impacts. Section on taking core. So core is very important. So what they do is they take core and they can describe rocks that they can't see at the surface, rocks deep underneath our feet. And they can do that in the oceans, they can do that on land, they can do that, as we learned, in ice. And what they do is then they can start describing the layers of the Earth below us and put together a story about the history of the Earth. About some of that, so drilling really deep into the oceans to understand the story of the Earth. And this is actually one of the ways they've also been able to help explain plate tectonics, along with a bunch of geophysical methods. This is a really cool map that I'm standing on top of. You'll see my foot out there. So this is a map on the ground that shows the blast zone from where the meteor impact happened that caused 75% of life at the late Cretaceous to go extinct. So the extinction event for the dinosaurs. And it gives you an idea about how massive it was, and also about the cores that they found that showed evidence of this extinction event as well. And there's been some really interesting scientific papers and research done on this topic. They also talk about things like plate boundaries. So the idea that the Earth is made up of plates, much like a soccer or what we call football internationally. And you can see these different plate boundaries based on the bathymetry here. And depending on the type of plate boundaries, you can be a little bit predictive about the types of disasters that could be associated with them as well, and how the Earth has changed through time. So you can back out those plate motions like a puzzle and figure out what the Earth looked like. That's how we know about things like Pangea, or land was all in one giant continent. And this is something I talk about all the time in my channel, and that's the layers of the Earth. They're like a cake. The oldest is on bottom, so if I'm making a cake, I put the first layer down and they build on top of it. The Earth is no different. It can then get a little bit more complex by things like mountain building, like here in the Himalayas. But we all start with the understanding that the oldest stuff's on the bottom, the youngest stuff's on top. And with that information, we can put together the story of the Earth, or of a certain portion of the Earth, or even a paleontology and the history of life on Earth. One of the fun things about being a geologist is you're always like a Sherlock Holmes, right? You're always trying to solve this mystery, put this puzzle together with minor pieces of evidence. And as you get more evidence, you can start changing your, what we call hypotheses or theories, if there's enough information, and adjust them as needed, or understand what are outliers and why they're there. Anyways, really cool exhibit here. Hey, here's a little bit about cartography and a cartographer. So a cartographer is someone who makes maps. And as a geologist, I make a lot of maps, and we use what cartographers do to help build our maps. Out of time, but they have a whole exhibit here for Catherine Lane Weems. And she was a bronze sculptor who looks like she really based her sculpting on animals. And so there's Afghan hounds, pelican, a Shetland pony. It looks like they have a whole hall dedicated to her artwork. With the building behind me, I want to say thank you for joining me today. That was really cool to check out the Boston Museum of Science. Lots to see, lots to do, and I just gave you a little bit of a taste of it. So if you're ever in Boston, definitely worth coming to take a few hours to check this place out, especially if you have kids. I can imagine this is just fantastic for them. I felt like a big kid in there. If you haven't already, please subscribe to the channel. If you enjoyed this video, give it a thumbs up, leave comments down below. Tell me if you've been to this museum, what you think about it. And with that being said, I will catch you all in the next adventure. Thanks for joining me again. Take care. Bye for now.